guys, welcome back. Greg Howe, S9 Radio, and thanks for tagging along for part 2 of the Browning Mark III 10-meter conversion, where I'll be showing you just how easy it is to put a Mark III transmitter up on 10 meters. Now, most people, when they think about transmitters, think about RF output. And that's fine, but I want to direct your attention to this 5 megahertz oscillator tube, V1. And for the V1 oscillator position, I suggest using a tank. A tank is a tube that is physically larger than its generic counterpart, and consequently they produce about 10% more output, making them ideally suited for the 5 megahertz V1 position in the Browning transmitter, as they provide a little added drive, really helping performance when working outside the normal 23 channels. This just happens to be a B759 Gold Lion. And next to some of the unobtainable vintage European and German tubes of yesteryear, I don't think money could buy a tube better suited for the V1 application than the Gold Lion. However, you don't have to break the bank with the Gold Lion. There are other high output 12AX7s, most of them coming out of Russia. Yes, they are tanks, and they will get you the same performance. However, the B759 with its super tight manufacturing specs is probably about the best oscillator tube you're going to be able to find. And for those of you planning on using a VFO for frequency control up on 10 meters, which I'm pretty sure is just about all of you, as rockbound, aka crystal control transmitters on the ham bands pretty much went the way of the dodo bird long ago, you're going to want to make sure and tune in to part 3 of the Browning 10-meter conversion video, where I demonstrate how to convert a VFO that utilizes a Colpitts oscillator, pretty much all the 11-meter VFOs, to go up, down, or all around in frequency, allowing you to tailor your VFO to your particular needs. Stay tuned. Everything's up to temperature, and I'm ready to commence with alignment of the transmitter. But first, let's go over a few things. The transmitter is still on 11 meters. The VFO has been installed on channel 23. The VFO has been dialed into 28,500 megahertz, which is basically in the middle of the sideband and AM portion of the 10-meter band, and this will allow decent performance on both without having to retune anything. If you're only interested in AM, then I would suggest tuning the set for 2900. However, I should point out there's a lot less activity on 10 AM, 29 megahertz than there used to be, with many of the old timers and their vintage boat anchor transmitters passing on. But I'm pleased to say I did get to hear a homebrew 10-meter AM transmitter this weekend, October 2024, with the guy's transmitter drifting up about 5 kc during his transmission. And that's pretty much par for the course in vintage radio. You never know what you're going to get. I've actually heard a guy's transmitter go snap, crackle, pop, and blow up while on air, with the guy coming back about 10 minutes later on a different radio going, well, that didn't go so good. I'm telling you, it's exciting. You get a history lesson. You guys got to check it out. And I'm talking about vintage AM radio. Regardless of the band, those of you that got Brownings, obviously 10 meters would be an easy one. The first step of this transmitter alignment is something you should all be doing often, and I'm referring to checking the bias of your transmitter. As the final tube ages, the bias tends to drift. So to check the bias, throw it in the sideband mode, either upper or lower sideband, meter switch in the MA, that is the plate current position, and go ahead and key up the radio with no modulation and center the needle for the center of the bias box. We are good. Next, we want to resonate the final by adjusting the plate tune. That has to be done very quickly, otherwise it imposes a fair amount of stress on the final. But before we start that, for those of you with the signal generator, go ahead and leave your set in sideband. For those of you that don't have an audio signal generator, just go ahead and put it in the AM mode. And I want you to have your watt meters on the lowest possible setting. The transmitter is still on 11 meters, yet we're asking it to perform over a megacycle higher on 28.5 on the 10-meter band. So the RF output is going to be extremely low. So low that many of you aren't even going to be able to see any deflection on your watt meters. And that includes the folks with the birds, unless you've got a 500 milliwatt slug like I've got here. Chances are the internal watt meter on the Browning transmitter is going to be a better bet to start out with this resonating of the plate. So let's have a look. I've got the meter in the forward position, and I've got the SWR calibrate all the way counterclockwise. I've got the signal generator going. I'm keying up you can see about 200 milliwatts with a 5-watt slug on the bird. Now watch this. I'm advancing the SWR calibrate. And yes, this is our actual RF power. Now this is really hard on the final. I don't recommend you guys key up and do it this long, but watch this. Now watch the bird watt meter and watch the Browning meter, and you tell me which is easier to tell when you're seeing some improvement. Look at that. Okay, I'm bringing it up to 10 meters. I'm adjusting the plate, and I saw a fair amount of movement on the Browning meter. I was not looking at the bird, but I'll bet you saw more movement on the Browning meter than you did on the bird. Once again, the Browning meter has excellent low power resolution. Now that the flea power adjustment of the plate tuning control has been made, optimizing the final for maximum RF output, one can proceed using the information outlined in the Browning Factory Service Manual, Sam's Photo Facts, or for a much more comprehensive look at the Browning Mark IIIs, including lots of color photos, check out the Service and Restoration Guide at the end of this video. Anyways, the 10 and 11 meter alignments are identical. However, this alignment is going to be more streamlined. Unless you've changed the V1 oscillator tube, there's no reason to even be messing around with any of the adjustments over here. We're going to focus on L5, the 16 megahertz oscillator coil, T3, T4, and T5. Bear in mind, these three transformers all have top and bottom slugs requiring adjustment. Those of you with the later model Mark IIIs are also going to have an L7 inductor right here that needs to be peaked for maximum output. Those of you with the very early model Mark IIIs have a C30 antenna trimmer control. I tune these into 50 ohms on the bench. If you've got a C30 capacitor, this is very, very useful for making your transmitter play nicely with amplifiers, especially solid state amplifiers. So for those of you that've got a C30, you might want to look into that. And then some of you, both early and late models, will have a neutralization capacitor right next to the final on the underside of the chassis, and that's for parasitic suppression. With the alignment complete per the info in the service manual, next we're going to optimize the transmitter for 100% VFO control, as I'm sure most of you don't have any 10-meter crystals. To do this, we're going to go back and readjust L5. What this is going to do is tune the 16 megahertz oscillator circuit to the additional load capacitance of the VFO cable and the VFO itself. You should see a huge power increase when adjusting the transmitter for VFO only operation. After that's done, I want you to go back and touch up the plate tuning control on the back of the transmitter, and that pretty much completes the overall alignment with the exception of parasitic oscillations, should you have any. So what is parasitic oscillation, you ask? Well, in our case, parasitic oscillation is a phenomena where the 75-58 final self-oscillates, self-driving itself. I prefer the terminology self-excitation. This self-excitation creates RF output when there shouldn't be any. And this is most easily detected in the sideband mode if you're seeing RF output or signal with no modulation. And notice I use the terminology signal. It's not carrier. If you've got carrier, you want to go back and with the combination of C8 and R4, null that carrier with the carrier balance. I'm assuming that had been previously done. But anyways, this self-oscillation, self-excitation is an equal opportunity destroyer. It does not care whether you use AM or sideband, and it will destroy a final output tube, an amplifier tube, lickety-split. It is a no-no. You do not want parasitic oscillations. Now, this is true of most vintage tube-type transmitters. If you've got a transmitter, when unkeyed, that's generating noise in a nearby receiver, or in the case of the Mark III hooked up to the receiver, if you're hearing any increase in noise with no antenna connected to the transmitter, there's a damn good chance you've got a parasitic oscillation. However, keep in mind aging carbon comp resistors as they burn internally and aging electrolytic capacitors as they break down internally can also generate a heck of a lot of noise. Remember I told you to crank the gain of the 16 megahertz oscillator circuit with this L5 adjustment, optimizing a transmitter for VFO operation? Some VFOs, the Makos in particular, can actually overdrive this circuit, creating a ringing that gets amplified throughout the RF stages, looking a lot like a parasitic oscillation. So to rule that out, let's reduce the gain by readjusting this L5, and if you're still seeing RF output on sideband with no audio input. Move over to T3, give it some adjustment, same thing, T4. T5 is usually not a culprit for parasitic oscillations. After adjusting everything, if you're still seeing RF output on sideband with no audio input, hopefully you've got a neutralization trimmer that Browning installed on some of the transmitters underneath the chassis right next to the final. And if that doesn't do it, try swapping the final. Oftentimes the final is 100% the culprit, and it had nothing to do with the alignment. Okay, guys, here's the end result of the 10-meter conversion regarding RF power out. With the transmitter in the sideband mode and being modulated with an audio signal generator and tuned for peak power output at 28,500, the transmitter produced 12.4 bird watts into a bird tourmaline dummy load. With the transmitter sporting the broadband alignment, as you're seeing right here, right now, that's a 10-watt slug. It's producing just a little over 10 watts at 28,500. Now I'm going to dial down to the 10-meter sideband call frequency of 28,400. And look at that, a little over 10 watts. Now let's dip down into the novice area of the sideband portion of 10 meters. I'm going to go down to 28,300. I think that's where it begins. And let's see what we've got. About 10 watts. Now I'm going to crank it all the way up to the 10-meter AM call frequency, which is 29 megahertz. And let's see what we've got. Wow, a little over 9.5 watts. Impressive, considering that's over double the design bandwidth of this 23-channel transmitter. Nice. Well, that's it for part 2 of the 10-meter transmitter conversion. Make sure to tag along for part 3, where you'll get to both see and hear the birds in action on 10-meter AM, filling the airwaves with the melodious sounds of the Browning ping. And then I'm going to show off a bit, doing a little worldwide weak signal sideband work, demonstrating the awesome performance these monobanders have to offer. And then, as aforementioned, any of you that want to learn a little more about VFOs and how to move them around in frequency, make sure and stay tuned for part 3. 73, Greg, S9 Radio.